We ready to learn something today? Chloe looks real excited. Real excited. Okay, hopefully we'll get some stuff done and then I'll have time to give you your stickers too, then I can keep up to date. Also, you should feel blessed because my other classes, I haven't given any of them stickers. Like, I forgot all their tests and stuff. I'm just behind. I'm just slacking. Everyone has a calculator in some form or another. If not, scoot your boot. The good thing is, too, I will eventually, this is the one I have, right? You need some solution for your eyeballs. Are you okay? Okay. I will show you how to do this, which is why I got this document camera. So that way I don't have to show each of you 52 times how to use a calculator. I can just put it on the screen. That's why this camera actually came. Okay, so we are going to do 3.1 today. The chapter 3 in general is graphing functions. It's going to be a lot of fun. But 3.1 is graphing linear functions. Ooh, I don't like that marker. Switch it out. Okay, so we have some vocabulary to talk about first, okay? First thing we need to talk about is what is a linear equation? Anyone have a guess? It's as basic as you think it is. Ty. It is an equation that forms a line. Exactly right. Obviously, when graphed. It's as easy as it sounds, right? Okay. Next thing is, do we know what a constant is? We already actually have talked about this. What is a constant in an equation? Correct. A constant is just a number. No variable. Do you remember what that word is called, or what the word is that represents a number that's attached to a variable? Coefficient, yes. I know that some of us did confuse those before. All right, so I'm just glad we're getting it now. Okay, now, we are used to equations looking like this guy, right? Y equals mx plus b. Do we all remember equations looking like that? Yes. Okay, now we are going to talk about a different form of equations. It is called standard form. Okay, standard form looks like this. Our letters are capitalized. A times x, our A's are capitalized, plus B times Y equals C. So AX plus BY equals C. My B and Y are a little far apart from each other, but they're supposed to be next. Obviously, what are the differences between the equation we're used to, where y is by itself, and this guy? What do you see? Y is not by itself. X and Y are on the same side, yes? And that's just for funsies, apparently. I can't tell you why they use capital letters in that one, but they always have. The big thing is first, X and Y are on the same side together. Do you see how X goes in front? Why do you think X goes in front? That's how the alphabet goes. That's why it says A, B, then C, right? Makes sense. Okay, there's a couple rules to this. First off, A has to be greater than or equal to 0. What does that really mean? A has to be greater than or equal to 0. It can't be a negative. AKA whatever's with x, whatever x is, has to be positive. Okay? X has to be positive. This is the first thing I always make sure of. X has to be positive. Then I go, okay, let's put x and y on the same side because we're going to have to put some equations in standard form. Okay, the next rule is that, and you will like this a little, but you'll hate it at the same time, I guess. No fractions. You're not allowed to have fractions at all. Which is why we had that one quiz question where it says, how do you get rid of these fractions but keep the equation? We're going to have to do that. We're going to have to keep our equation exactly how it is, but get rid of the fractions using multiplication. Okay? And the last rule, which is usually, we don't use it as much, but it is important. A and B and C can only have a GCF, so have a GCF of 1. What does that sentence mean? Or statement? It's not really a sentence. What does that mean, though? I know you just read what I said, but what does that mean? No. Yeah, but what is a common factor? You're still using words in my sentence. Try to use the words without try to describe something without using the words from our sentence. Yeah, so we have 3 numbers. None of them can be divided by anything except for 1. So I couldn't have 2, 4, and 6 because 2, 4, and 6 are all divisible by 2, right? So they all have a GCF of 2. If that's the case, we would have to actually do that. We'd have to simplify it, is basically what this statement says. This statement says that if these numbers have a GCF that's greater than 1, we need to simplify it by dividing it, whatever that is. So if our numbers are really big, usually if they're all double digits, they usually have something in common. If they're all even numbers, they at least have the number 2 in common, yes? Okay, so first thing we're going to do is we're going to mix these two concepts together. Is it a linear function? And then if it is, we're going to put it in standard form. Okay, standard form is the hardest part. Okay, first one. Y equals 4 minus 3x. So it says determine whether each equation is a linear equation. That's the first sentence. How do we know if something's a linear equation? By looking at it. Because we can't see the graph, can we? So we're looking at the equation. Do you know what about this tells us it's a linear equation? Does anyone remember? What about your variables tells you it's a linear equation? It's not in our definition. This is to see what we remember. Its location actually does not matter. The locations of x and y don't matter. It's their properties of x and y matter, because can't x and y look different? Can't they have things around them that change them? I'm thinking of special words that Braden likes to use on the first day, like superscript or subscript. What's the difference between x and x squared? This means I have multiple of them, yes? This means I only have one of them. A line is only allowed to have the power of 1 on all its variables. That's a big star note informational thing. Wherever I'll have my variables, power 1. That also means X has to be by itself. What if I put X and Y times each other? Can I do that and still have a power of 1? The variables together, how many powers do they have? They both have 1 power, don't they? But since they're multiplied, they kind of have 2 powers actually, Ty. So the answer is no. So you're only allowed to have, for linear equations, you're only allowed to have an X and a Y separate. No multiplying variables. No variables in the denominator. Can't have that guy. You're only allowed to have X and Y. No Z, no Q, nothing. This is all you're allowed to have. This is a perfect example of a linear equation. So this one, the first sentence, this is yes, it is a linear equation. So yes, linear. That's over there. Second part, can we take this equation right here and put it in standard form? Remember, standard form means X and Y on the same side. What was the first rule we talked about? So always look at X. Is X positive? No. If X is not positive, then you should probably move him so he can be positive. Because if I move him to the other side of the equal sign, is he positive? Yeah. So move him to the other side. Just move on over. So now I have 3x plus y equals 4. Now are X and Y on the same side. Do I have no fractions? Perfect. Do I have a GCF of anything other than 1? No. How do I know that? You can't divide anything. You only have to check 2 numbers. Check X and Y. 3 and 1. Do they have anything in common other than 1? Nope. As long as you can check 2 of them and they say no, you can move on. So this is your answer, and then this would be your other answer. I hate circling answers, but that would be it. Okay? So then looking at, you still have your instructions. Looking at this one. Y equals x squared minus 4. The first question. Determine whether each equation is a linear equation. Is this a linear equation? No. Why? Not linear? I circled the thing that's not linear. If it's not linear, can I put it in standard form? No. So we're done. That's it. Easiest problem we've ever done. Okay. What about this one? 1/3 times y equals 1. Now, is this a linear equation? Does it still make a line? Is the power only 1 on the y? Yeah. It doesn't have an x, but that's okay. Think about your lines. You can have all the lines you're used to look like this, like my pen, right? Diagonal. But isn't this also a line? Isn't this guy right here also a line? Well, he's a little straight. He's a little crooked. Right? Didn't we already talk about the vertical line test already? So isn't he technically a line? So he is still yes. He's still yes linear. Standard form is just going to be a little funky. Because put x and y on the same side. Well, is y on one side and the constant numbers on the opposite side? Aren't we already there? Okay. Next part says no fractions. Uh-oh. We have a fraction, don't we? What's the denominator of that fraction? So how do we get rid of that number? What by 3? Everything. The whole entire equation by 3. 1/3 times 3 and 1 by 3. Everything gets multiplied by 3, no matter what, because the 3 has to get rid of that 1/3, and then the 1 has to be inflected. Ooh. So what's 1/3 times 3? 1. Or you can just put y, and then equals, what's 1 times 3? Okay, thank you. Lots of options. The most basic option is using parentheses. Hold on, let me grab it out because they're turning and looking at me. Most basic option is if you had 1/3. Let me turn her on, right? Okay. 1/3 times 3. You could put. I always put all my fractions in parentheses. One. Zoom in. Light. Now can you see it? There we go. I always put all my fractions in parentheses because that's how we make sure we don't make mistakes. You literally just do 1 divided by 3. 1/3. 1/3. And then you literally just close the parentheses on your fractions times 3. Well, 1, that's a dirty word. 2, no. All of your answers should be mixed numbers. If you have one, let's just take 2.25. That's an answer, right? I had to push enter. On these things, you see how you have a second button, and then this says alpha. That's for the alphabet, which we never use, by the way. And then the math button is your best button in the world. Math button, what's that first one say? Fraction. That says whatever your answer is, it'll turn into a fraction. Guess what kind of fraction it'll always turn it into? An improper fraction, because it's the most correct kind of fraction there is. So with these calculators, you'll always get an improper fraction. And also there is a way in the mode button. It's right next to second. I can't look at my screen when I talk to you. There's all these things going here. There's a way, and I can't remember what it is right now. There's a way to automatically turn your answers to fractions instead of decimals. I just don't remember what it is off the top of my head. It's easier on Braden's calculator than it is this one. I just don't remember. Because yours should have one that says fractions or decimals. Auto. Okay. Auto should be fractions. Yeah, so you have options for types of fractions. N/D is numerator over denominator. Blah, blah, blah. And then what's the other one? UN over D. Huh? Yeah. UN over D is improper fractions. That's the one you want. This one you can do it too. It's a different thing. Also, just in case, you see how, so whatever's dark is the thing that you're picking, right? It's like selected. You want to always be in degree mode. You want to have the word degree highlighted. It should be like second or third down. It should be at the top. So yes, scoot over, be on degree, push enter, click on it. So it won't affect you right now, but degree mode helps you basically function in what 2D. That's the best way I can describe that for you. And then when we move into the next class you have me for in algebra, you switch between the two. Okay. But degrees, you know how you take a percent and turn it into a whole number? Degree mode is what that's for. Radian mode is like a completely different thing that if your goal is to take calculus, you'll learn all about. Promise. Okay, but fractions, right there. I don't remember what it is right now, but the best thing is Google. He's your best friend. If you don't remember or know how to do something, you just Google it. But I'll look it up how to turn them on to straight fractions because I always use fractioning. But if anytime you get anything, it'll always, if it gives you a decimal, just push math, enter twice. It'll always give you the fraction answer. Every single time. And if for some reason you want the decimal, you can go down to the second one and pick decimal. Yeah. Okay. Okay, let's do one more of these. Okay. 4. How about 3/4 x? Oh, I put 3/3 on my paper. Okay. 3/4 x equals y plus 8. I hope that you know that's a 4 because I said it even though you can't read it. So again, is this linear? Do my x's and my y's, they only have a power of 1, right? They're not multiplied by each other, right? And you have no variables in the bottom of a fraction. Okay, then we're good. So yes, it's linear. Okay, now the real question is, how do we put this? I'll turn that light off. How do we put this in standard form? Now, we want x and y to be together, but who has to be positive? X. Is x already positive? So are we going to leave him alone or are we going to move him? We're going to leave him alone. So what are we going to do to keep x and y on the same side? Yep, move y to the other side of the equal sign by subtracting it, right? So then we're going to have 3/4 x minus y equals 8. Now, next question. Do we have any fractions? How do I get rid of that fraction? Multiply what by 4? Everything. And just distribute that 4 to every whole number in there. Do you know what happens when you have a big number 4 and a little number 4? They just cancel out and you just have the numerator. All it's going to do, whatever you multiply by, is cancel out the denominator, and whatever's in the numerator, that's your answer for x, or whatever was the top of the fraction. GCF. We good? Yes, Aubrey. I did. 3 times 1/3. Look at this. 3 is the same thing as 3/1, yes? Okay. 1/3 is 1/3. When you have the same number on the top and the bottom, I just shoved this up. When you have the same number top and the bottom, those numbers cancel out, which is why we got the number 1y. Yes. Does that make sense? All the whole parts. Again, if this equation would have had this, I'm just going to throw a wrench in it. What if my original equation would have had this in it? Not linear, right? Then we couldn't have done it. Okay. Good. First part, and I think the first part of your homework, let's do the pixies. Yep, first 6 questions. Done. Okay. Moving on to the second part. Oh, I gotta get a new board. Oh yeah. Really, second part is the last part. Oh, I'm zoomed in. What is this? It is where the graph goes through the x-axis. What does a point look like that is an x-intercept? Like a point, right, is an ordered pair. What does a point look like that's on the x-intercept? Like that is an x-intercept. Like x-intercept 3. What does that look like as an ordered pair? X-intercept. It's always a specific number. It is x, comma 0. An x-intercept is always whatever that number is, comma 0. Every single time. Because, just like it down, if we had a picture, right, it is crossing this axis right here. This is our x-axis, right? Left to right, that's our x-axis. So if we have a point on this line, it has not moved up and down any. So y is what value always? 0, which means if we're looking at a picture, we can easily look at a picture like this and go, oh, x is 5, right? That's pretty easy. If we have an equation like this, 2x plus 4y equals 6. That's almost 16. I can't read. 2x plus 4y equals 16. That's almost in standard form, other than it has a GCF. If it says, what's the x-intercept here? We'd have to figure it out. What did Dana just say? X is a whatever x is. What's y? Always. If y is always 0, what do you think I can do in this equation to find my x-intercept? Huh? Cover it up. Yeah, so, yeah, but use your math terms. Substitute in 0. We just said y is 0. So then plug in 0 for y. So you have 2x plus 4 times 0, which again is just 0, right? So this really means nothing to us, doesn't it? 4 times 0 is just gone. So you just have 2x equals 16. Now I only have x left. Can I easily divide and tell me what x is? AJ, what's x? 8. So whether I'm looking at a graph, which I can use my eyeballs for, or I'm looking at an equation, can I find my x-intercept? Yes, ma'am, you can. Then, same thing with the y-intercept. Well, almost. Using your words, how do you describe what a y-intercept is on a graph? Correct? How do we write a point on the y-axis? 0, comma y. So that means x is always, yeah, the thing you're always looking for, the opposite's always 0. And again, if we're thinking about a graph, we can use our eyeballs and go, okay, that's my y-axis, the up and down one. Remember, y has a tail. And if we're looking at the same exact equation, what am I going to do to find my y-intercept answer? Yeah, plug in 0 for x, right? So then it's just 2 times 0, which really means it's nothing. 4y equals 16. So 4y equals 16, which means tie y equals 4. So if it asks you for the x-intercept by itself, you would just say, hey, x is 8, man. If it said, hey, where does the graph intersect the x-axis, you'd have to say the legitimate ordered pair. Then, for giggles, it'd say, hey, graph this. Can you graph this equation? Well, did you just get an x-axis, your x-intercept on your x-axis? Did you just find your y-intercept on your y-axis? How many points do you need to make a line? Did we just find 2 points? Heck yeah, we did. That's all you need, right? That's all you need, which is why I give you that, because look, if not, they look like that, and that thing's just bowing out. Right? Y equals 4. Point. X equals 8. I'm not trying that. I'm just going to put it over there. Connect and extend. Easy. X-intercepts and Y-intercepts are way easier than making a table and doing all that stuff. And if it, oh, my leg's stuck. Okay. How about, and if it asks you to do anything other than find the X-axis and Y-axis to graph it, don't. Just make the X and Y intercepts because that's silly. Okay? So, for example, I'm going to zoom in on this because my drawing's not that good. If I give you a table, I'm just going to cover up the work. Haha. Because no one wants me drawing this. Okay. Ooh, the real question is, can you then see it? What does this do? I'm sliding. Don't mind me. What did you do today? Watch Miss Ronaldi struggle with the document camera. It's focusing. Okay, you see that graph. 5. Can you read it? There's a picture. It says, find the X and Y intercepts on the graph of each linear equation, and then then try to describe what the intercepts mean. So can anyone raise their hand and try their best, because it's hard? Tell me where the X-intercept is. Jimmy. Yeah, that's 25. Okay. Chloe, can you tell me where the Y-intercept is? -4. Does anyone, Chloe, can you just tell me what the Y-intercept is representing or what it means? You have to describe it using this picture. So what you do is you look over here and try to read what that says. I'll give you a hint. It says Fahrenheit on it. Yes. So it says, so how would you describe that? I tried to focus it, see if it would help. It did not, by the way. So how would you describe the temperature? Like, how do you describe that point? Because you can't just say, oh, Y means temperature. You have to describe, my Y-intercept is -4. So that means after, go ahead, Ty. You just mixed 2 intercepts together. You did the statement was correct, the numbers were wrong together. 25 minutes, what was my degrees? No. You have to think about the ordered pair here. What's the ordered pair at your X-intercept? 25, 0, right? So 25 minutes, 0 degrees in temperature. -4 degrees in temperature, how many minutes? 0. So they're backwards. The answer is right there, kind of in the thing. So you can't mix them together. That was a nice thought process, Ty. But you want to think of that point individually. So you go, this is my Y value. What was my X doing? This is my X value. My Y did not go anywhere. Remember, the other's always 0 with intercepts. Okay? If you look at, I didn't even have to move it other than it's crooked. If you look at that table, can you look at a table? I tried to focus it. It's not going to work. Can you look at a table after it tries and see where the X and Y intercepts are? This one's just, can you read to know what things are? What are my order pairs for my X and Y intercepts? Can anyone find my X intercept for me? Lila. X intercept, which means X is a number, Y is 0. Anyone? Aubrey, you want to try? The bottom one, it says 12 comma 0. Can anyone kind of maybe see where the 0 is in the X and there's a number for Y until my computer just decided to take a nap? Chloe? Jace? Somebody? The first one, yep, 0 comma negative 24. Good job. See, this is why I don't draw. Okay. Let's go back to writing because that was way easier. Okie dokie. I'm going to give you a problem. The instructions say, ooh, let's zoom back out. Seeing the scratches on the board. You can see all my absolute value notes from the last time. The instructions say graph each equation by using the X and Y intercepts. So why don't we try this one, which is negative X plus 2Y equals 3. That'll be your first one. And number 2, Y equals negative X minus 3. There's 2 of them for you. Oh, yeah. Mm-hmm. Your y-intercept on number 1 is going to be a little ugly. Oh, no, I meant to. Do we get our answers yet? I'm still hiding them from you. I just fixed my first graph so we can graph on it. You know you're doing it right if you get the same x-intercept for 1 and 2. Michelle, did you get an x-intercept for number 1? Okay. Do we all get -3 for number 1? Okay. Do we get a y-intercept for number 1? Is it a fraction / a decimal? Jace, what'd you get? You switch your fraction around? I think you flip-flopped. I think it's 3/2, sweets. Because you would divide both sides by 2. 3/2? Do we get 3/2? Okay, yeah. You switched them, which is what we did on our quiz, right? We talked about this yesterday. It's what some of us were doing on our quizzes. You switched it, sweets. And then number 2, we'll graph in a second. Do we also get x equals 3, -3 for our x-intercept? And our y-intercept? Okay. Does anyone want to feel, I fixed number 1's graph. Does anyone want to feel, I don't know what's the word, gutsy to try to draw the graph? To do it on the board? My graph's already up there. You just got to plot the points and draw the lines. Yes, ma'am. It's because you're just writing them wrong. That's the answer. Because you guys did it on your test that way too. This guy right here. X is 0. So you got -0, which is 0, plus 2y equals 3. So this was not important. I get y by itself. Divide by 2. You probably typed it in backwards. And then now it says, oh, never mind, because it gives me one and I just bet you, and I bet you like $1 million you just typed it in backwards. Yeah, I did. I did. Also, 2 and 3 are both what kinds of numbers? Does anyone know? Prime numbers, yes. So you never actually have to type them in. 2, 3, 5, 7, right? 11, all those numbers. Really, anything, as long as they're not both even. Most of the time, whatever you divide by, fraction is already your answer. If you want to know what the decimal is, so that you know how to plot it, if you don't know what this is, a decimal, you can always look, but like, this is just 3/2, which is okay, so a lot of you can do this on your test too, is you'll probably get the right word here and then you are typing them in backwards. Because you'll say, divide by 2. You're doing it right, and then you're saying it wrong. You're typing it wrong. But you all do it. I blame the ghost. Your entire class does it, so I'm just gonna blame them. Anyone want to grab through? You guys never come to the board. My class comes to the board all the time. Brain good. Brain. They Oh my goodness. Where's my mouse? Ah, remove! Where is it? Okay. I know, but I should still be able to stop it if I can see it at the bottom.